Hi everyone. Today we've got some quick notes on rationalizing radicals. Let's begin with the warm-up. We want to simplify the expression 9 root 7 over 3 root 14. So we know that dividing radical terms, we can just divide the numbers in front, so 9 divided by 3, and then our radical, the square root of 7 over 14. Simplifying, we have 9 divided by 3 is 3, and then square root of 7 divided by 14 reduces to 1/2. Now, what do you notice about the result? In your own words, see if you can summarize what you notice about our result. Well, one thing I notice is that there is a fraction in the radical. You may have actually gone a little bit further and separated this back out into a quotient of two radicals. So if you had 3 root 1 over root 2, well, we know what the square root of 1 is. That's just 1. So you might have also gotten the answer 3 times 1 over root 2. Okay, so your answer as your observation for the result might have been that there is a radical in the denominator. Okay, so because there's a radical in the denominator or a fraction inside the radical, we have to rationalize this denominator. Or in other words, we have to write it as a rational number. We rationalize the denominator to make better sense of the quantity, right? It's easier for us to determine exactly what that quantity is if the denominator is a rational number. Rationalizing the denominator means rewriting the fraction so that the denominator does not contain a radical. Note that rationalizing the denominator does not change the value of the fraction. So the only thing that we can multiply a term by that doesn't change the value is the multiplicative identity, which is 1. So if we can multiply the fraction by a clever form of 1, that's not going to change the value, but we can see how that affects what our term looks like. So using the example from the warm-up, where we had 3 times 1 over root 2, or you could also write that as 3 over root 2, if I multiply this by 1, notice how that doesn't change anything. I can multiply by 1 all day, right? Nothing has changed here. But consider this. What if I multiply by 1 over 1? Does that change it? Well, notice that 1 over 1 just reduces to 1. So no, I have not changed it. This is just multiplying by 1. Well, likewise, I could multiply by, say, 2 over 2. Well, 2 over 2 is also just 1, right? Because 2 divided by 2 is 1. So again, still, I'm not changing the fraction here. But then what if I multiply by the square root of 2 over the square root of 2? This is also a clever form of 1. So the square root of 2 divided by the square root of 2 is 1. So if I multiply root 3 over root 2 by root 2 over root 2, I'm not changing the value at all. I am just multiplying by 1. And let's notice what happens. When we're multiplying fractions, we just multiply straight across. So we have 3 root 2 over, well, root 2 times root 2 is, I'll just write it out this way for now. But if we multiply root 2 times root 2, we have the square root of 4. And we know what the square root of 4 is. That's a perfect square. The square root of 4 is equal to 2. So by multiplying by this clever form of 1, we've now eliminated the radical in the denominator. And we're left with this final answer of 3 root 2 over 2. All right? Let's try example 1. So here, let's go ahead and rationalize these radical expressions by multiplying by a clever form of 1. So for part A, I'm going to multiply this by the square root of 5 over the square root of 5. And notice that's just another form of 1. As we multiply, let's see what happens. We have 3 root 5 over the square root of 25, or 3 root 5 over 5. Part B, let's go ahead and multiply by the square root of 2 over the square root of 2. And we have 4 times the square root of 2 over the square root of 4. And the square root of 4 is 2. So we have 4 root 2 over 2. And I noticed that, well, we can just divide 4 divided by 2, and I'm left with 2 root 2. So this 4 can be divided by 2. And last, let's go ahead and multiply part C by root 3 over root 3. Another clever form of 1. So we have 4 times the square root of 24 over the square root of 9, which is equal to 4 root 24 over 3. And I know that the square root of 24 can be simplified. So I have 4 times the square root of 4 times 6 over 3. And I know that the square root of 4 times 6 is the same as 2 root 6. So I have 4 times 2 root 6 over 3, which is equal to 8 root 6 all divided by 3. And that's our final answer. All right, so in summary, we rationalize the denominator by multiplying by a clever form of 1. Most cases, it's going to be that same radical that's in the denominator over itself. So in this case, root 2 over root 2. In this case, root 3 over root 3, and so on. All right, we're going to get a whole lot of practice on this in class, so we'll see you tomorrow. Have a great day, everybody. Goodbye.